boards with the analog device chip on it. So anyway, playing with the IDT, I had done a lot of work with 408 megahertz and kind of thought I'd do my way around things. I hit the IDT and all of a sudden I found that there were a lot of things that I had to figure out that were new. So it did turn to be kind of a adventure in constructing it. So, okay, first, what is the IDT? Well, we got the itty-bitty telescope. Really popular for demonstrations. A lot of them have been built over the last 10 years, so we need another presentation on, another go-around on putting them together. It's an educational tool. It's, very well demonstrates what a radio telescope does. It's not really useful as a scientific instrument.
You didn't tell us that last year, did you?
What?
False advertising. I didn't hear that disclaimer last year.
Well, I didn't talk on it last year. But anyway, it's not a scientific instrument. But anyway, there's where they come from. KU satellite pieces, which, those you watch dumpsters and watch alleys and, the junk piles, and they show up sometimes. So they're usually available for free. Had a few problems to solve that, we're kind of new for me working with this compared to the 408. First, you have to find a dish with a usable LNB, and I'll talk about that a little later. You need to find a dish that's not bent or dented. I mean, sometimes they've been dropped off a roof or something, and they have to be accurate within a few millimeters surface accuracy. And if they haven't been banged around, they do meet that qualification. Getting a usable satellite finder, that was an interesting adventure in itself. Okay, then needing to power the satellite finder and LNB was not too bad. Stable mount, I had some differences on how the mount should go, and then figure out where the heck are we pointed with this thing, which initially was a bit of a problem. And then there are some dishes that have the oval shape rather than the slightly off round shape. And the proceedings, I questioned the usability of those because when I did an internet search, I found out they don't have a parabolic shape. They've got another shape so that they don't get too far out of whack when LNBs are put off axis. But upon looking at it further, the central part of the dish with the smiley face is close enough to a parabola that, it's great for the purpose. Part at the outer edge, it needs a special, feed geometry to work with it because it's an odd shape. But they are, in fact, usable. Okay, look at LNBs. I found, we had a pointer up here somewhere, so I pointed those.
I think it's right up here, Bruce, in front of that remote control.
Okay.
Look
No,
further
that's
over,
a pin.
look further over.
Ah, here we go. Now, let's see. Okay, find the end of it that I keep my eye away from. Okay, that was the simplest LNB things you found, and those work quite well. When I was playing with them to find out if they were useful or not, I was drawing arrows on them and stuff to see which feed went out, which connector, and that kind of thing. So that one, of course, got two connectors for two polarizations from the feed. Those has no problems. This one with the two LNBs in a housing. It turned up, it got 12-volt power on it. This LNB comes out this connector, or this LNB comes out this connector. And got to think about, how did I find out what LNB was hooked to what if you need a signal source? So this is a precision microwave signal generator. Compact fluorescent bulbs, the gas inside when they're lit is about 10,000 degrees Kelvin. It's a very low pressure, so it doesn't melt the glass or anything, but still it's close to 10,000 Kelvin, mercury vapor arc. You can bring this in front of a feed like that, bring in front of it. When that goes in front of the feed, your satellite finder hooked to it, it goes crazy. It's a quite effective signal generator. And then when it's mounted on the dish, you can hold this out 15 feet away from the dish and carefully aim the dish, and you can hear this thing buzzing away and see your meter go up and everything. So it's a quite effective signal generator, 12 gigahertz, and I don't have anything else in my home lab that will go that high. The highest I go is 4 gigahertz in equipment. So having this turned up to be, like I said, very precision signal generator.
Where's the cal sticker?
Oops, it's missing. Okay, it's not calibrated, so it's not precision. I have to get a cal sticker on it. Anyway, the LNBs, that's how I find you put that light bulbs in front of it. This one, it was powered through that jack. yeah, you put the light bulb in front of here, it, responded, and it wouldn't respond to that one, so I figured out which was which on that. And the two are close enough together that one little almost round dishes works, fine with that. This one was kind of interesting because it had for 3 separate satellites in different positions in the sky, but they each came out a separate connector. So these two would be very useful. These are off-center on the dish, so it would make aiming pretty confusing, but I suspect it would still work pretty good. And just hook up to a satellite finder, 12 volts, wave the bulb over it, learn a whole lot about it pretty quick. Here's some not usable LNBs. The pieces that are being passed around, when I tore that one apart trying to find out, well, what's in it and how do you control it kind of thing. And it's got quite a messy control system inside it. And somebody might be able to come out with an Arduino processor and program to send signals on the coax cable to work it, but I'm definitely not there. If you take a look at this feed, this one, the central portion is the same as that. It's got 3 feed horns, it's got a clear cover, and then it's got 2 other feed horns here. This one, by the way, has 3 feed horns, 3 waveguides going back to polarization separator, 6 waveguides coming in. So take a close look at that piece when it's going around. It's really quite a work of art, microwave pies. I was fascinated by the construction, even though it was not useful for the purpose. Did learn a lot on how to put together. Okay. Now, one of the things I did is I reversed the mount. Almost all of the satellite TV dishes have the feed arm on the bottom. Up here, this is the IBT. You look at the GBT, the feed arm is on the top. So that's obviously what you have to do. You can't put it on the bottom and have a good telescope. I mean, the GBT obviously does it right. But the main reason for doing that, well, first I put a sturdy tripod under it of unknown origin. It might have been for speaker stand or something, but anyway, it's a little beat up and needed a lot of band-aiding. I replaced all the bearing bolts in here, which were 1/4 inch with 3/8, and the pivots are in a different place. I've got the main pivot here now instead of here. When I initially put it together, I put this little gizmo from part of a Harbor Freight tool there to be a stop. And then, of course, I added a handle to it so I could move it. That handle isn't exactly right, but it's headed the right direction. So anyway, the 3/8 bolts were an important part of that. When you're drilling holes for something like that, if you drill the hole a 1/64 of an inch under the desired size, and then drill it through very carefully with the desired size drill bit, your holes will fit a lot tighter. And either that or read the holes to size the other thing that can work. But you want those bolts to be nice and tight so that the thing, will aim and stay in place. Now there's the Harbor Freight cheapy T-bevel thing that I took apart, and the angle finder, and just took that thing out of the box, tore it apart, threw the lower part away, drilled an extra hole in it with a pivot point, and it worked pretty good. It was not as good as I wanted. Okay, there we have my thing there. I've got a level setting across the 2 sides, but that bolt in the front, piece of fiberglass sticking up there with a little magic marker mark on it, is by sight. You use it like rifle sights there, so you can tell right where it's aimed. And that's very useful for demonstration purposes, because you can get people to look down at, like astronomy club, and everybody look down the sights. Okay, that's where it's aimed. I did make one mistake on the sight there, that put it together with double-sided tape and didn't have any way for it to fold down. Well, it actually broke off in the way to green bag. I had a tie wrapped in place on the unit sitting out in the hall there.
Is the straight, is that the dish is flat, vertical?
So right here, that's like that. So that's horizontal. The dish is aimed right at the horizon there. In other words, the feed is up above. The center of the parabola is right here. The missing part of the parabola is here. The rest of the parabola is down here. And where it's aimed is, right there. I, lit up my signal generator down there, 20 feet away from it, and moved it up and down so it was aimed at it. I would find the sights were aimed just about on the signal generator. It'd be slightly off because, 15 feet away is a little too close. And then there's a tilt with this of about 18 degrees. So the little angle finder thing, you put it there and know what your elevation is, but you got to do the mental arithmetic. So next step is a block of wood carefully cut to size, then a little piece of steel on top for the magnet to stick to. And that'll get the elevation pointing. I'm still working on what to do with azimuth pointing at this point. Okay, well, I wasn't 100% satisfied with the way that others, the little T-bevel thing worked as a positioner. So I got this. This was another $4 item at Harbor Freight, the cheapy stuff. These woodworking clamps, when that is released, you release that little lever there, the thing will slide back and forth. And at first I removed this handle there thinking I didn't want it. Later I put it back on because that's a very good way to get the dish angle just slightly low, and then move it with that. You can get it right where you want it, much more accurately. So in fact I ended up putting that back on after taking it off. I left this part of the clamp on so that you wouldn't bop yourself with it. It wasn't actually used. So there it is, put on the thing there. You can see that part of the clamp, it's laying there, but not really used, but it keeps somebody from injuring themselves running into it. Put a piece of aluminum bar across there to anchor that down, and that basically that left the motion much easier to use. One thing I found, the handle tended to run into the clamp there. So next go around on the handle, I'm going to make that handle a little longer. I'm going to put a 45 degrees of bender so it goes out that way, and that will leave it somewhat easier to aim. It is quite usable now. Okay, take a little closer look at that. I've got some bits and pieces there. The clamp, in order to get a bearing point here, I took an old volume control with a 1/4-inch shaft and threw away the volume control and put the bushing through a 3/8 hole in here. Then a 1/4-inch spacer, I ran a screw into the block of wood there, being very careful to keep it straight, so that gave me the bearing on that end, and it proved to be a very adequate bearing and pretty cheap, quick and cheap to throw together. See, you can't see, you can see it right here. You can see there's a piece of automotive fuel line put there and held in with a couple of tie wraps. That is a stop so that if you let go of the dish because it's not balanced, gravity will pull it down, so that keeps it from going clunk, and rather it just kind of goes flat if you run out of experience and let it go. I think what else we got there. Kick a beer and stop. The wood block has its own set of problems I'll talk about in a second there. Well, it turns out that the bottom of most of the satellite dishes will go on a 1 5/8 diameter pipe. The tripod I got, 1 5/8 pipe would fit into the sliding part there. I said, oh, that's fine. Well, when I went to the block of wood, I check around and I say, oh, I don't have an 1 5/8 drill bit around, one of the hole saws or the little flat spade bits, which work real well. And I checked a bunch of catalogs and stuff. It seems that nobody wants to make an 1 5/8. You can find an 1 3/4, an 1.5 inch, but you need an 1 5. So I use one of the fly cutter things. I don't know how many people have experience with those. That's one of the things, you make sure you have no loose clothing. It's more dangerous than a chainsaw. Basically, you feed very slow. One hand is doing the feed, the other hand is on the on-off switch in case something goes wrong. In this case, it went through pretty smoothly, but those things always make me nervous. So the 1 5/8 hole in the wood was the most irritating and nerve-wracking part of the whole thing.
Back in Harbor Freight, did you look at their set of Forester bits?
Yep, they do not have 1 5/8. You can get an 1 3/4. Every place I look, you can get 1 3/4. Now, I later found one place on the internet where you can find an adjustable bit you can adjust to 1 5/8. But anyway, nobody makes a hole saw that size, and I would have just went and bought the tool because I figured I'd use it eventually. Anyway, that wasn't real irritation for me, 1 5/8 hole. Maybe somebody else will come up with a better way to handle that. And look at the range of movement that I've got on it there, and it goes so that I'm looking a little bit below the horizon, not up, and it moves pretty nicely over the whole range, except that the handle is getting, kind of in the way there. Like I said, I need a bend in that, and that'll leave it pretty good. Okay, next thing, satellite finders. I had looked at making one of the IBTs about 10 years ago. I bought a satellite finder, which was like 40, 50 bucks, something like that. It had been laying around. And this 10-year-old one, it actually worked pretty good. It had smooth readings, it had a variable tone pitch, So when the signal went up and down, you could tell it. There was no erraticness or anything with the readings. It really worked quite well. Unfortunately, those haven't been made in many years. I got this old cheapie on eBay, and I found that this one is very lacking on dynamic range, erratic readings. It has a tone that comes out of it is variable amplitude rather than variable pitch. Your ear, of course, is much more sensitive to a slight change in pitch. I mean, especially musicians like me, a musician back there, I mean, they cringe at a slight change in pitch. They notice it. But all of us will notice pitch more easily than amplitude. So, I prefer the pitch. Well, this one had variable pitch. It's kind of interesting. And I've got the schematics of some of this stuff actually in the appendix to my paper. But that one, the meter movement actually moved quite nicely in response to signal level. I tested all of it with signal generator at 1 gigahertz to find their behavior. That's how I saw this one was erratic. You couldn't quite tell what was happening when you were just hooked to a dish trying to move. You could just tell something wasn't right. But it became immediately obvious with the moving the signal generator up and down. Well, this one, the needle, real nicely follows the signal generator. The problem is that the tone pitch is erratic on it. You change it, the tone pitch would suddenly jump up or jump down when it reached certain points. And it turned out the oscillator that makes the tone was hooked straight to the speaker, and resonances in the speaker would reflect back into it and cause, almost phase lock the tone source. And then when you went a little further, it would suddenly jump. Now I put a resistor in series with the speaker in there, so now it's not loud enough, but the crazy jumps went away. It was actually well behaved. So that one, maybe with a little audio amp chip to drive the speaker rather than driving it directly, would probably work pretty good. It was a $10 item, so not expensive. But that one would have been, at least usable. And then, of course, the Channel Master was what a lot of people used very successfully. It seemed to be very popular. The problem with it, they haven't been made in quite a few years, and you can find one that's been kicked around on eBay. That picture was actually stolen from eBay's site there. Anyway, so then that look board that I'm passing around is that board, which is one of the little Chinese-made demo boards for a 8318 analog devices chip. Look at that chip. There's no way you want to try to mount it on hand. You just don't want to do it. And considering the chip is like $7 and it's like 11 or 12 bucks for the board, you really just want to buy the board. But its output levels are a little lower than desired, so you need an amplifier before you went into the A to D, the 10-bit A to D. It's actually pretty good on the Arduino boards. So with an amplifier to scale, it should be able to go in there, and then the Arduino board can generate a tone, and even send it out your diagnostic port. Your program can also use it as a serial port and pump data out there. So there's a way to maybe pump it into SkyPipe. I need to talk with Jim Sky a little about that. And all of the younger people, if they have any computer savvy, seem to know what an Arduino is and seem to be at home with it. It's got a quite easy and free development set for it. So you buy the board for $10 for a Chinese-made one. You hook the USB cable to your computer, download their tools, and you're off and running. So it's one of the easiest things I've ever done as far as microcontrollers for programming. Did a little testing with the signal generator on my little board there. I drew a line which is the expected logarithmic slope. And then you can see about minus 60 dBm it is beginning to deviate from the logarithmic slope, and right on up to about plus 5 dBm. So it's pretty well behaved over that. And then I took a look at, well, what level comes out of the LNB when it's looking at various things. So I was looking at everything from cold sky to clouds in the sky to the fluorescent light bulb test generator, and cold, warm ground, stuff like that. People walking in front of it. This seemed to be about the range of signals I saw, which is a reasonable amount of range here to work with about ½ volt. So you need about ½ volt. But some of the LNBs have more output and would run down here, some of them less and would run down there. So you need a way to take a half-full part of the span, but you want to select your half-full part to match what your LNB does. So that, I kind of looked at what's an amplifier need for that. And there, I had thrown that into a SPICE model, so that's Some of this stuff is about, power, signal source, PWM from the processor. All that was just, that's for modeling, but, from here over is a schematic what goes in there. LMC 662 is because I have some of them in my junk box from another project, and they're a very good CMOS input amplifier, well behaved. And basically the PWM on the processor would be used to change the offset to set the part of this, the half-volt range here, what parts you want to fit the ADD converter. So you change the pulse width, which easy Arduino command, analog out, in parentheses, a number between 0 and 255, and the average voltage here will settle to that reasonably quick, according to your filter. And then a little filtering here to get rid of noise and run it into the ADC. That has only been computer model, hasn't been built yet. So that's what you might call vaporware in the software industry, something that doesn't exist yet, but you're trying to sell it. So I'm trying to sell something that doesn't exist there. Sorry about that. Okay, then take a look at a block diagram of this whole thing. I'd have my, first I would have some kind of choke so that I could get 12-volt power to the LNB and a little capacitor. So I need some kind of bias key in front of that little detector chip. And then the DC amplifier, and the last thing, Arduino. One of the PWM outputs would go to change the offset on this. Serial data output to that the USB debugging interface. Once you're disconnected from the debugger, like I said, you can pipe data out there. So just need to work with Jim Sky on a format on that. Then take another one of the PWM channels, run it through a filter and a meter. Because I like the idea of a big analog meter, and I found one laying around my junk box, fairly big and nice, so that would go on there. Then an analog out on a set of jacks maybe, a little audio power amplifier, and the tone would be one of the outputs on the Arduino. And then to set it up, I was figuring you get those little encoders, and they're only for like $1 or so for an encoder, $1.50. And as you rotate them, they put quadrature pulses out, so the direction you're rotating changes the phase of these pulses. And there's Arduino software around to decode those already, so you don't have to write it. Then I figured I'd have a button here that I'm holding that button and turn the knob, I'm selecting the gain. If I'm off the button, I'm selecting the offset. So I can move it to scale whatever I want here. And then, the tone, you might want to turn it on or off, so just an alternate action is what I figured on. So that, again, that's in the vaporware class. I'm going to be working on that. So, a couple of Sara journals from now, we should have a final working version of that, I'm hoping on. Okay, so what are we going to do with the Arduino? Process, user inputs, set the gain and offset on that DC amplifier and match it to the needs. The other thing, the detector is a logarithmic output, and it would actually be advantageous to have a linear response to temperature on your output. And that can actually be done quite easily because the Arduino has a fair math library in it. Do floating point. So you take your 10-bit in from the ADD converter, float it, and run it through a few, analog and other such math, which is sitting in the library, easy to use, and then convert it back to your 8-bit code to go back out to your, meter stuff. Generate the variable pitch. There's a little thing I found on the internet for making musical notes with Arduino, where you want pitch pretty accurate, and it ties up, I think 2 outputs or something. It ties up a little more than it should, but there's still enough. And then generate the meter drive, and then ship the data out to serial port. Those are what I visualize the Arduino doing. Okay, proceedings have some information on finding the sun and the moon and satellite belt, stuff like that. For where I am, about 35 north of the equator, you can generally look up on one of the satellite setup websites, and they'll tell you, from my house, minus 5 degrees declination, and you're into the satellite belt. I used Jim Sky's radio eyes program to find out where the moon was, to make sure its declination is well off the satellite belt, because I actually did sense the moon with that thing. And what I sensed, it was a very small change, and it didn't show up on the meter, but the variable pitch thing is what I did is I aimed the thing close to the moon, and then I moved the handle around with my eyes closed and listened to the pitch, and moved it around, got the highest pitch, and said, okay, that's max signal. Locked it down, opened my eyes, and looked down the sights, and sure enough, it's aimed right at the moon. And I repeated that about 5 or 6 times, and I found I could consistent. It wasn't much of a change in pitch, but that says that's with, yeah, the moon is within reach of that. Looking for the sun, you can run into kind of a nasty surprise there if you're not careful. At first you think, well, the sun's 10,000 degrees Kelvin, the horizon is around 290 degrees Kelvin, that should be a pretty good difference. Well, the beam is a little over 3 degrees beam width, about almost 3.5. So the sun fills, if you take a half degree of sun over 3.5, that's about 1/7, and it's about 1/7 of the aperture, or the beam pattern, I should say, in both directions. So that means you got about 1/50th of the temperature of the sun actually shows up there. So that means 10,000 degrees Kelvin comes to 200 degrees Kelvin. So that says you want to make sure the sun is well away from trees if you want to try to find the sun reliably. Otherwise, you may find a tree that looks hotter than the sun. And of course, you always want to make sure that stuff's well away from the satellite belt when you're looking at it, because the satellite belt is full of stuff. But you get about 10 degrees away from the satellite belt, and it's good and quiet.
Satellite's the brightest thing out there, I think, isn't it?
Satellite belt?
Yeah.
Yeah, satellite belt is the brightest thing out there. There's no doubt about it. When you find it, you know it. I mean, you can go there, without any preliminary. They just kind of move it around a little bit, and you'll hear a satellite, and then move in, and you get on a satellite. Now to know where the belt is, and you just find the satellites right on across there with no problem, without any compass or anything else. It's just randomly move around. You'll find the satellites. They're loud. So, like I said, 10 degrees away from it, it seems like the satellites aren't much influence. So that's about what I have here. Any questions?
I take these to I take one to the Dayton Ham Bench, and most people are amazed when they got it.
Yeah. Well,
I insisted that was possible.
Well, it's interesting. Probably 6 months ago, the astronomy club said, "Well, tell us something about radio astronomy." So I put together a show and tell, and the 408 one had been done. There was a few people kind of nodding off. I think maybe even one fell asleep kind of thing, And then I get the IBT and have a little explanation about, okay, look at the radio telescope almost as a thermometer. It responds to temperature, and point that out that it's going to respond to the temperature of things. And you point out the effective beam width versus the size of what you're looking at, and you don't go on too long about that. You take it outside and you aim it at people. Aim it at street lights. In my case, there was cars going down a road in front. You could aim it at cars, and every enough cars actually seemed to be colder than the background because the metal was mostly reflecting the sky. So it seemed like they generally resulted in a drop in temperature when a car drove by the beam pattern. Get people walk in front of it, and it shows what a person's temperature is. You want to be careful about when somebody walks in front of it and you see the indication of temperature, don't say that they're hot. That's not necessarily cool. You could get yourself in trouble. Any other questions? Yeah.
So a long time ago, there was an experiment done to see if objects that are metallic can be seen inside of enclosed buildings by using millimeter wave receivers and large phased arrays, and they actually were able to image cars. You're mentioning cars in a true to thought. They were able to image cars inside of wood buildings. So here's a thought. You said you can see a car, but what if you put a piece of plastic in front of the car?
Well, yeah.
In front of the telescope.
Well, now if you hit a glass surface at a low angle, it seems mostly reflective. If you hit it at a higher angle, it looks like it goes through it. It's apparently related to the dielectric constant of, and therefore index refraction of glass.
Experiment to put a big one of those, maybe those roofing fiberglass sheets or those translucent light cover things, like those things up there, and put it in front of the antenna before you see the cars go by, and say, you can also find cars invisible.
That's true.
If the car was behind a plastic building, we could determine that there's a car there.
Yeah, provided the plastic is
sufficient, right? Yeah.
Really clear at the RF frequencies involved.
Yeah.
That is an interesting thought. That might be another thing to add in the demo for that.
I saw a picture, and you could actually tell it was a Jeep Cherokee inside a garage. I only saw that picture once, and I've never found it again, ever. It's gone.
Okay, so for
like,
all you guys that showed the IBT at your astronomy club, there's another possible thing to entertain people. You know, astronomy clubs, hand clubs, you know, junior high school kids.
Kids love it.
Yeah, junior high school kids, if you talk about radio astronomy as fun science or physics, you have, you know, a lot of eyes glaze over, you'll have a couple of kids very interested, and that's it. But you show something like, yeah, the IBT, and everybody's, you know, everybody's awake, and they learn something despite not wanting to not learn something, you know, they can't help but learn something. So, yeah, I think it's a great training tool, and yeah, I managed to see the moon with it, and I don't think we're going to see anything other than the moon and the sun with that as far as astronomical objects. So, see on that. Any other questions or comments? Yeah, Jim?
Are you going to complete this with the circuit board and your Arduino code and, or is this just
Okay.
hypothetical?
Okay, the Arduino code I should get, you know, completed before too long. As soon as I get a bunch of contract work off of my desk, you know, you retire and all of a sudden people that you worked with before said, oh, I know who can fix that, so you got a contract job. So, and it's hard to walk away from the money when they want to pay you 90 or $100 an hour, you know. So it'll be worked in, kind of in between, you know, contract work. But I hope to buy, not the next journal, but the one after that, I hope to have some, you know, code, you know, hook up and stuff. Now, making a little board for the DC amplifier, myself, that's the type of thing that I'd wire on a little wire wrap board or, you know, wire tangle, whatever you want to call it, or, you know, hand wire it on a little perf board, something like that, because there's not that much to it. If there was a real market for satellite finder things, then maybe I could get somebody to, you know, make up a bunch of boards, but I don't want to be stuck with a bunch of boards, even though they're $1.50 a piece. So you're stuck with 100 boards. It's, you know, getting to be real money.
I think Far Circuits could make a bunch of boards, not boat limit, but maybe 20, 30. Relatively cheap.
Okay, yeah, and it could be done as a single-sided board, so don't need plated through holes and all that if you go through whole parts. So that's a, you know, possibility. So anyway, I'm looking at that. You know, getting the code going. I've played with Arduino enough that I have a pretty good feel for how to make it do things. So I think I won't spend too much time coding it, despite the fact that I'm not the best C programmer. You program it basically in C, and most of my experience has been programming in Fortran or Pascal. And you know, you use those two, and then you look at C, and you're sure the letter C stands for cryptic. But anyway, so I'm still learning my way around C, but you know, I have played with the Arduino board. Sure, I'll get there in a reasonable period of time. Any other comments, questions? Yes?
The IBT DVDs that we sell on the website are woefully out of date. Would you please consider creating a whole, another video and set of documentation for the IBT?
As time permits, yes.
Okay, that's the only answer I need.
Yeah, because you know, it sounds like the big thing is that I don't know if some of I saw satellites on the internet, $300 or $400 for satellite finders for, you know, somebody that makes their living lining up satellites are probably a good deal. They may have pretty good, you know, reading capability. They might be very
Do you have
good.
a set of the old discs?
For the IBT?
Yeah.
You will.
No. Yeah, I will after this.
Look over, update them, redo them. Thank you.
Okay, so you know, hopefully with time I get the next version of the disc. Like I said, the amazing thing about it is how people that have almost no astronomy background, very little technical background, are immediately interested in it, and people like the pitch. The fact that pitch varies. You'll even see people taking and moving their hand in front of the dish up and down, you know, and then, hey, Mary had a little lamb, you know, and okay, you know. So people can play a tone with the variable pitch if they've got a good ear and a good hand, I guess. So I have, you know, people like to play with that variable pitch. Yeah. Also, the IBT that I built is sitting out there, and I would actually like to have everybody take a look at it, and you know, they might see an idea or two, or they might be able to tell me how to do something better, in which case I'd be very happy to take their suggestion. Because, you know, especially if I'm going to be helping with the next disc of it, you know, any good ideas that are around, appreciate it. Anything else? Thank you. Yeah,
I saw those
yes,
boards.
get my precision signal generator out of the way here.
Didn't want it to be handled by white. It'd be laying somewhere in a fiber. And actually, there's
There's like a two, like sandwich in the show.
Well, guys, we're about to wrap up. Mr. XVP said I had to do something, so I threw together something the other day I thought was pretty neat. A lot of people don't know about this. 2 years ago, I went around and found it, so let me just go through it. It's less than 3 minutes. This is a horn 120 foot long, and it was used for calibration instrument. And it was built 1959, and you got a building down here, you got a horn, it's open, and there's steps to it. Well, that was years ago. And a little bit more information. It's got the aperture 17 by 13. It's got a centered band weight guide on the back. This was made to look at cassette calibration. Just all it was made for. In the days, they thought cassette was an excellent RF calibration source that never changed. We've now found that it is decreasing. It took about 50 minutes to go through it, and they were measuring about 2370 Janskys back in the 60s. The book that the other gentleman was selling, there's a little bit of information on page 80 or so that I found that was pretty deep, and some information. So everybody goes, where is it? It's hidden. No, it's not hidden. This is where you eat. This is where we are now. We're going to go up this direction. And right here is the wastewater treatment plant. There's the end of the mechanical area. There's the 20 meter, the T-tail, and the 40 foot that we go on. You're going, where? Where is it? Well, if you look behind the 20 meter, they store vehicles here. Oh, look at that little item right there. That's a very inclined hill. And it's like, it's just there. And there's a calibrated 300 degree Kelvin device in front of it. And it's just, if you go over there, I've got some notes, but it looks very, very creaky underneath it. I did not
You
even
just
get
put
there.
your droppings in there?
The air conditioning was in the backside. If you look at one of those pictures I've got, it's done underground rusted. That door was locked. Well, no, maybe open, but you couldn't see anything in there.
What, was the electric meter still running?
Okay, I'm getting there.
Oh.
That's the industry I'm in. I'm in electric meters, but that's the competition, and they shouldn't have it there. But the electric meter is still running. That's about $35 a month. My camera did not capture the reading, so I don't know if it's incremented since the other year. But the electricity's still there, and the Brant Canyon Trail is an easy way to get to it. And I didn't know they had trails here. So here's the 40 foot, and this right here, this little house here had that little one on the side. It's called either Looney Bin or Nut Bin. Can't remember. You go down there and go behind it.
Nut bin.
Nut Bin. You go behind it, take a right. It's there. Or if you're crazy, you get in your car and you can drive to this field and pull in. It's right there's the.
You can get stuck there very easily.
So, but the grass was grown up 2 years ago, and I was stomping as I was walking because it looked very incredibly snaky. So, and that basically I just said, don't climb on it, don't make those sue in, fill out paperwork, don't go underneath it, and don't let us get kicked off. But it's, we were talking about trying to get a Class A project. I'm going, this instrument's sitting here, and there may be a possibility.
Let's see, in 1991, I think it was, Jim Carroll hooked a receiver up.
Somebody, Jim Sky or Carroll?
No, it was Jim Carroll.
And it pegged it, I think. And they undid
he had
some
too much.
connector.
He had too much gain in there, and it actually pegged it out. I guess he figured wrong on the aperture of the Janskys or whatever. But anyway, it definitely sensed it.
And the other one I heard is they undid some connector and a bunch of water come pouring out. So
yeah.
And that's what they said. It has an open.
Carl Lister told me yesterday that he is up to it.
Yes, Carl had the story, and he told me about this thing. I said, "Where is it? Oh, it's right over there." So I finally went putting around, and the Bing map was the good map we saw. But that's it. It's just I was trying to do a little thing every conference on historical instruments that I guess are dead or dying, or that may be pretty
Yeah.
neat.
Little
I
amplifier.
heard that they
IDP.
actually detected the cosmic microwave background of this horn. They were investigating noise sources, and they came across that one, but they ignored it.
What I will promise you is I will try to come to the Green Bank, because I'm only 5 hours away, and look in the library and see if I can get some more information and put it in the journal. That's, I didn't do this justice, but it's there. It's not really worth seeing, but if you're totally bored, Jim, what do you rate it, a 2 or 3?
Oh, more than that.
More than that?
A lot of fun.
So, but it's grown up a lot. I mean, you can't really get near the building and go up, and you try to go up the stairs, the wood looks real bad. So I'm not sure what's up in the building, but that's it.
Up there.
Anything else? Has anybody missed any details?
Well, he's not here.
In a way, it's too bad they didn't build that horn at, Cygnus A, which of course would have been tilted up a lot.
Yeah.
It'd been a lot harder to build. But Cygnus A is much closer to stable.
Yeah, that's true. I was noticing the information. It's like they were saying so.
I mean, yeah, because it's a supernova remnant. As it spreads out with time, it drops off.
But I feel certain that if we get Reichart involved, we may have a project. I don't know what that is, but something that we could do.
A third of.
And so, we were asking today, in our group, any chance of, them reviving it, and the lady didn't say no, so, I don't know. There's, one of the issues here at the telescope, obviously, is each group has their own little kingdom, and like if we can get access to the Tatel, it's, you gotta be safety, and the guys that move it are, hydraulic type guys, and it'd have to be greased and all that, so it's, every little group is a kind of a kingdom. And I won't say you have to lubricate their palms and pay money, but that's kind of how this whole facility operates, is, you have to supply money, but,
Is it more like a
nobody's told us no yet.
kingdom or fiefdom?
And more like fight. So, but I mean, it's sitting there, if it won't fall down, maybe.
Well, if we wait long enough, the recession of the earth will take it out of the.
Yeah.
So good it can come
So, I just thought it was nifty, it's one of the things you never heard of, and if you didn't know it was around there in the woods, you was like, where is it? So, that's it. Any more business?
Nah.
Do you guys eat now?
No, I guess we're gonna have a drawing for prices.
Who doesn't? That's you. Where is the,
Who's got the tickets?
this man has to have it.
Before we do that, if you were here last year, you may remember that we had can somebody help me put something on the screen? I've got something here on.
No, I didn't.
It was in big time, somebody deleted it. All right, just bring me up, let's browse, bring me up over here. Yeah, all right. Okay, who you did? Okay, well, we're doing.
Yeah.
Look at our screen.
I'll have you give you access to that.
That's to me.
You got three.
Okay, if you were here last year, you may remember that we raffled off one of these. It's from RF Consultants. The guy builds these. And actually, I think you talked about the chip last year, right?
Yeah, I talked a little about the chip when I was
Right,
talking
and
about
this
phase noise.
This is using the chip that's in there. It's a frequency synthesizer that goes from 35 to 1750 megahertz. It has and it's very accurate. It has a very accurate internal 10 meg oscillator, and you can also use an external 10 meg. It's calibrated in output from minus 55 dB to plus 10, and you can set it up to sweep both in output and in frequency, but not at the same time. And it has a crystal detector in it, so if you go out into an amplifier, come back in, it will actually draw a curve on the screen. What happened to my?
Is that the Stuart Rowley one, or am I getting confused with somebody else? Stuart had a,
I can't watch my, okay, I want to go down. Just scroll down, or I'll use the arrow key or whatever. Well, this is the software, it runs on a PC, it's USB driven, and it has RF outputs over here. You can actually put audio in to modulate it. So if you want to have your own FM transmitter or radio station, it's got an auxiliary power input, which is normally driven just off the USB. Scroll. This is kind of what the base screen looks like. There's a whole bunch to it, but keep scrolling down till you see a graph display. A little more. Oh, no, well, you can't quite, you can almost see the red line up there. That's a test feeding output into an amplifier, taking the output of the amplifier back into a detector, and then displaying it on the screen. So you basically get a curve, a gain curve on amplifiers, and it does lots of other things too.
Or a
Now,
scalar network analyzer.
Yeah, and the only reason I'm bringing this up is because the way we do raffles, first come, first serve, okay? And all I'm saying is, if you don't think you really have a need for this, don't take it. Unless you want to sell it on eBay, which would break my heart. But anyway, it's there. The other box we have is a DVD, CD copier. We ended up with 2 of them in Sara. We don't need to. It's one of those, last generation things that if anybody thinks they need it, fine. If you don't feel like you have to take it. If you're the last person, I'll take it back home with me and get rid of it.
Which one is which?
The big box is the copier. The little white box over there is the signal generator. Now it comes with a CD on the signal generator, and every unit is calibrated by serial number. So the output in dB, there's pads in there that the manufacturer programs into it so that it's very well calibrated, and it's pretty close. Okay, put a 20 dB pad on the output, you got a minus 75 dB output, you can calibrate stuff. It's amazing, it really works. Okay, any questions?
You said it converts what to CDs? The other larger one?
The big box it copies.
Yeah, copies from
CD and DVDs?
Yes, DVD and CD. You just put it in, it automatically detects it, you put the blanks in, you can do it 3 at a time.
Okay, copies the same thing.
Right. In case you need multiple copies, like we do, because we send out a lot, but I don't need 2 of them.
Okay.
You just be like China.
Sure.
Sounds more so.
Okay, so, big bag of tickets. What I do is.
Right here.
Okay,
I was gonna get,
Vice President,
well, I was gonna get her to do it.
there you go.
The oldest member of our group.
Now, the other thing, there are books, there are some other things over there that you are welcome to take.
949. Obviously, it's 39.49.
I got to fill that's my wife, because mine was 39.48.
So the guy who did after you.
Is she outside?
She went to the gift shop.
663933 for this one.
No match on either of them? Okay.
Okay, how about third hit?
Come on. Get back to work, Amelia. I'm just teasing you.
663932. Oh, that's me.
Well, you get
Yeah.
to pick.
Okay.
And the person who gets the first one wins, they get to pick the second one, so we continue.
Your dad won't like it.
Check the whole box. Check the whole box. And you get to pick
It's a
one
nice
more.
instrument, you'll enjoy it.
You'll like that.
Will she let it play with it?
I presume she'll let you use it.
Pick one more.
Yeah.
I'll get on the list.
663904.
Oh, no, 3904.
Yay! Here you go, here's your ticket.
I think this one and this one.
Okay.
Don't you need a 3X?
No, I don't. I'll take just a book. I'll take a book, that's all I'll take.
Think a mouse
What's
pad.
that?
Or a mouse.
Where are all these tickets coming from? Did we draw that many already?
No, it was these three.
Okay.
Those were,
Oh, these are the ones that you
Okay.
663945. Oh, come on, that's me again. Does anybody want
How many
this?
tickets did you have?
she's got a racket going around.
Does anybody want this?
Just draw again.
Gotta go through the.
Hey, Amelia, just draw another ticket, sweetie.
I was hoping for
Okay.
more, but you've got a bias tea or something in there, right? Or something.
663910.
990.
1-0.
Okay. Thank you. You picked mine.
All
Let's see
right.
what's on that.
How did I get these many tickets?
No, I don't do recipe.
Yeah.
That was loud. I'm happy.
You have to put your hand here before you get your prize. So continue on.
Oh, okay. Well, there's
Do I still have my
07,
other
3907.
3907?
Oh, that's me.
I think you need a duplicate.
Yeah.
Okay.
You want to try it?
How many do I have, first off? 6? Wait, they call it, okay, this calls. Wait, did I say it?
3917.
3917.
Yeah.
3917.
Okay.
3911. Yay, winner.
Thank you, Vinny.
No.
Wait, can I still get the light?
Oh, absolutely, yeah.
$395.
3940. 3940.
Yeah, that's it.
3940.
No, this one, the one that you got in.
What do you got?
3940.
Go for it. Pick one. $39.23.
Me.
$39.51.
Oh, come on. that was
51.
next to mine.
No 51?
How long?
$39.37. 39.37.
3947.
37.
37.
Going once? Twice? There's a finite number here. We got it. 3948.
Oh, come
Come on down. You're 3935. This one's 3899. 3899.
We have that. It's right here.
on.
Come on. Give me that. Grab another one out of there.
3944.
3944.
$38.98.
3898. Going once, twice.
$39.50. Oh my gosh, that's mine.
Put it back in.
What does she have?
She got yours and yours?
All in here.
So where'd you get them all?
Keeping her.
Oh,
She keep putting the same one back in.
No, I keep running.
39.18.
I want her to play Powerball for me.
39.14.
14.
39.26.
Did everybody leave?
39.38.
Raise her hand. What number is it?
I don't see John Cole here.
39.15.
115.
39.30.
Oh, that's me.
Hey.
This one's 3936.
Look at all.
3936.
I don't know. I just picked something.
Man thing. Okay.
And this. And that.
Yeah. 3900. 3900. There you go. It's 3941. There we go. Here you go.
Yeah.
3942.
Two college students who are around
Where's
here.
your sarcasm shirt?
A couple of them went to
I don't know.
college.
It's still a cool shirt.
Oh, John Cole had the,
Oh,
his dad
take
and
that one.
mom did as well.
This was 3903.
Three,
Oh, come on.
there's three of them missing.
3903.
I'm a great picker.
She's gonna try one more time.
39. Wait, did it? They already called 39.10.
3919. Next. $39.47. 47?
47?
47. $39.49. 46, 46.
That's you.
$39.22. Still two. 39.24. 24. No 24.
Same drop.
$39.20.
Actually, I don't even know that.
$39.29.
Your phone goes right here.
I got 29?
You're not gonna advance with it.
Go ahead, take some more bucks back.
Yeah, the only thing that's different is that.
Trying to avoid that.
39.31. Need 31s? Yep. And then I got 39.06. That last one's me, so that's it, we're out.
Oh, thank you for taking that. A long drive back to Tampa.
It could be. Perennial prize, the gift that keeps on giving.
See, never.
Did I miscount?
They're all like, no more.
Yeah, but I don't have any more information.
Okay, well, the only thing is that
Okay. Dinner's at 5. You want to eat? Be there 15 minutes early.
Okay, did plans ever get firmed up for next year conference day?
No, that's what we're just talking about. They haven't got a confirmation yet.
No confirmation yet, okay.
As for planning,
oh, I have one thing. Go ahead.
maybe quickly now, yeah. I have to use some gloves. This is on airplane mode. The best guess, it will be August 5th, 6th, and 7th in 2019. The best guess. It's tentative. We're tentative there.
Is that for Sunday, Monday, Tuesday?
That is Monday, Tuesday, Wednesday.
Okay, so it's really the 4th, and then that week will be coming in.
And we're just.
No, they were going to try to come in on Monday because when we come in on Sunday, the cleaning staff has to come in over the weekend, and that's not their normal work hours.
So it's Monday afternoon?
Yeah. Yes. The Monday afternoon they need to start.
Wednesday,
Yeah.
and then leave Wednesday night or Thursday.
Yes. So, Monday, Tuesday, Wednesday, and then Thursday morning we leave. So that's tentative as it stands now.
I have the email list here. I'll hand them out as you walk out the door. Please check it over. If you see something that's not right, let me know, and we'll send out an addendum on an email list. Okay?
Thanks, guys. Trying to close it.
Anything I want, maybe I can coordinate with Steve.
You don't have any luck.
Got a small one here.
Okay.
Now, one request.
That's way too
Hey,
far.
Ed.
I don't really see this one.
I don't know where my laser pointer went. Oh. Did I put it down? That was I had. Mine has it on the head. Okay, I think that's what I used.
Notice they didn't collect store $100.
That was, I don't have a laser pointer. It had a real high special.
And I found out that mine, with the
That little board that you had, would be 8313 on it. There's another one on eBay, some European puts out with a 12-bit DVD that talks SPI to the RV. So that gives you a little more resolution than the 10-bit. Yeah, so it's 4 more bits there. It's on eBay. It's 80, 83. There's a whole bunch of them, but there's one that
works fine.
what I did. I used it. He has a power supplies on there.
I'm gonna have some fun with this, and I'm gonna make some money.
Same with the.
Yeah, good luck on that.